Hello बच्चों, let's read the question. Examine the origin for continuity and differentiability in the case of the function f defined by fx is equal to x times tan inverse of 1 by x when x is non-zero, and when x is 0 the function's value is f of 0 equals 0. Solution start करने से पहले let's note down the key concepts for this problem. So the key concepts are: first, definition of continuity. So a function f is said to be continuous at a point x equals a if limit x tends to a fx is equal to f of a. The second key concept is a function f is said to be differentiable at x equals a if limit x tends to a fx minus f at a divided by x minus a exists. Then the derivative of f at a is equal to the value of the limit, that is limit x tends to a fx minus f of a divided by x minus a. The third key concept is, suppose we have a limit of the form limit x tends to a fx times g of x, where limit x tends to a fx goes to 0, but limit x tends to a gx does not exist. But we are given that function gx is bounded function. Then limit x tends to a fx times gx is equal to 0. Understand, here we have function fx, limit x tends to a fx goes to 0, but function gx is bounded function, and if we multiply those two functions and find the limit, then the limit will go to 0. So with these concepts, let's now start our solution. The function given to us is fx is equal to x times tan inverse of 1 by x for x not equal to 0 and 0 when x is equal to 0. So to check continuity, of f at x equals to 0, we have to take limit x tends to 0 f of x. So this limit is equal to limit x tends to 0, x is not equal to 0, so the functional definition is x times tan inverse of 1 divided by x. Now understand that here limit x tends to 0 of x is equal to 0 and limit x tends to 0 of tan inverse of 1 by x does not exist. Further, we have function tan inverse of x is bounded by minus pi by 2 and pi by 2. So we have tan inverse of 1 by x is bounded function, and x, limit x tends to 0, x goes to 0. So the final limiting value for this limit is 0. And also f of 0 is equal to 0, so therefore limit x tends to 0 fx is equal to f of 0, and so therefore f is continuous at x equals 0. Now let's check differentiability of function f at x equals 0. So for that, let's evaluate the limit x tends to 0 minus of fx minus f of 0 divided by x minus 0, which is equal to limit x tends to 0 minus. So when x is not equal to 0, the function is x times tan inverse of 1 divided by x minus f of 0, that is 0, and here divided by x. Since x is going to 0, not equal to 0, then we can cancel out x and x, and we are remained with limit x tends to 0 minus of tan inverse of 1 divided by x. Now as x goes to 0 from the left hand side, that is the negative side, so x is less than 0, and so therefore 1 divided by something going to 0 from the negative side goes to negative infinity. So tan inverse of negative infinity is, so the limiting value for this is minus pi by 2. Now let's compute the value for limit x tends to 0 plus of fx minus f of 0 divided by x minus 0, which is equal to limit x tends to 0 plus x times tan inverse of 1 divided by x divided by x. Again x is going to 0, not equal to 0, so we can cancel out x, and we have limit x tends to 0 plus of tan inverse of 1 divided by x. Now we are approaching 0 from the right hand side, that is the positive side, and thus 1 by x then goes to positive infinity and tan inverse of positive infinity, so the limiting value for this is positive pi by 2. And since both the limits are unequal, therefore f is not differentiable at x equals 0. So this is our answer. I hope you understood it well. Best of luck and thank you.